In the last video, we have learnt as how to apply the kernel of a required shape and how to specify the padding. In this video, we are going to learn as how we can increase the number of filters whenever we perform the convolution operation. That means how to use the parameter of filters. So let's see how we can do that. Now moving on, observe the next cell I have written over here. Here in this cell, I have specified my filters as 3 in my Conv2d layer. See, if you observe my Conv2d layer, I have specified my filters as 3. And along with that, I have specified my kernel size as 3,3, padding as same, input shape as my input image, which is nothing but the dimension of my single input image. And I'm applying this entire Conv2d layer on my input X. So let me do one thing. Let's get the intuition as what is happening here whenever I make use of filter. So as we know already, I'm having an input image which is having a shape as 28, 28, 1. This is an image with single channel, and on this input image I'm applying a kernel which is having the shape of 3, 3. And when I apply this kernel with the padding as same, I'll be getting my transformed image which is having the shape as 28, 28, 1. So this is what we know already. Now what is this concept of filters? Now to understand this, first let's understand this term, that is kernel. See, this kernel is also called as filters. Okay, if this kernel is also called as filter, what does this filters is equal to 3 means? See, this 3, 3 refers to the shape of the individual kernel or the filter, and the filters is equal to 3 refers to number of such filters, or in other words, number of such kernels. Here what it means is I am using this 3 cross 3 filter 3 times, or in other words, I am transforming my input image using this kernel of the size 3 cross 3 3 times. So if I am applying this kernel 3 times on my input image 28, 28, 1, then my resulting output or the resulting image will be of the dimension 28, 28 into number of kernels, that is 3. So this is the behavior whenever we apply the filters on my input image. So let me just execute this cell and then we'll take it further, guys. So I'll just execute this cell. Okay, we now have the output as 1, 28, 28, 3. I hope you now understood as how this output is getting processed. Now to get the better understanding as how this particular number of filters works is, I have written as y is equal to layers.conv2d and the filters as 256 and kernel size as 3, 3, padding as same, and the input image is also having the same shape, that is 1, 28, 28, 1. Okay. Now, using our understanding that we had just now, what do you think will be the output shape of the y? As I've said already, whenever we apply the kernel of the shape 3 cross 3 with the padding as same, I'll be getting my output which is having the same dimension as 28, 28. Now, this number of channels dimension will get changed based on the number of filters. So in my case, I have specified my number of filters as 256. So my output image will be having 256 at this last shape dimension. Okay, so since I'm having a batch size as 1, which is nothing but a single image, my total y shape will be 1, 28, 28, 256. So this will be my output shape. So let's just verify it. If I execute this cell, okay, we have the shape that says 1, 28, 28, 256. Now, to bring back the concept of padding, what I have done is in this cell, I have specified as filters is equal to 256, kernel as 3, but padding is equal to valid. That means I'm not using any padding over here. So if I don't use any padding, what do you think will be the output, guys? I'll be losing a dimension on each side. And since I'm using 256 filters, instead of single channel in the output, I'll be having 256 over here in the transformed image. And since I'm having the batch size as 1, I'll be having 1 over here. So my resulting image or the shape of my output y will be of the shape 1, 26, 26, 256. And the reason I'm losing this dimension because here I have specified my padding as valid. Valid is nothing but no padding. Okay, so let's just execute this cell and observe the output, guys. See, if you observe the output, we now have the shape as 1, 26, 26, 256. Got it? I hope this gave you a clarity as how these various arguments in Conv2d operation works. Now moving on guys, here like before I end this video, what I have written is like I'm using my input of the shape 1, 5, 5, 1. This is the same example which I have shown or which we have shown in our previous videos of theoretical section. So if you observe in a theoretical section, we had made use of the example of the input image of the shape 5 cross 5, isn't it? So what happens if I have an input image of the shape 5 cross 5 and apply on my Conv2d layer? Let's see. So as a next step, I am creating my X, which is a tensor with the shape of 1, 5, 5, 1, and on this input image or this input X, I am applying my Conv2d layer, and this Conv2d layer has the filter as 1, which is nothing but a single kernel, and that single kernel is having the shape as 3 cross 3 and the padding is set as valid. So padding is set as valid, that means there is no padding, and since there is no padding, when I apply this Conv2d layer or this Conv2d operation on my input X, I'll be losing a single dimension. So let me just execute this. Okay, as you can see, we now have the Y, which is having the shape as 1 cross 3 cross 3 cross 1. Now I'll want to repeat it over here guys, because we'll be using this concept in our upcoming videos, and this is very important as what these each value represents in the output, because this plays a very important role whenever we are taking the baby steps and whenever we are doing everything in a hands-on manner. Okay, so this one represents the batch size, height, width, and the number of color channels. Whenever I'm inputting, it will be number of color channels, but once we transform it, then this one refers to the kernel size. Got it? I hope this gave you a clarity as how this convolution operation works. I know we haven't gone through to the mathematical concepts yet, and we'll be looking into that in the next video. But for now, I hope this gave you a clarity as how the dimensions of the input image changes based on the various parameters that we specify in this Conv2d layers. Okay. Now what I want you to do is I want you to create a matrix which is having the shape as 25, 25, 3. Create my X like this. Let's say 1, 25, 25, 3, and try applying on this Conv2d layer and see what is the output that you get. I want you to try it and let me know in the comment section, and we'll be looking into that in detail in our upcoming videos. But I want you to try it before you jump into my next video guys, because it will be very beneficial for you if you practice in a hands-on manner. Okay, so I hope this video has been helpful to you, and I'll see you in the next video.